Module 1, Section 1.3, Linear Regression. Objectives. Objective 1, calculate slope as a rate of change. Objective 2, draw scatter plot and calculate linear regression using a calculator. Mathematical modeling. Mathematical modeling is the process of using mathematics to solve real-world problems. This process can be broken down into 3 steps. 1. Construct the mathematical model, a problem whose solution will provide information about the real-world problem. 2. Solve the mathematical model. 3. Interpret the solution to the mathematical model in terms of the original real-world problem. In this section, we will discuss one of the simplest mathematical models, a linear equation. Objective 1. Slope as a rate of change. If x and y are related by the equation y equal to mx plus b, where m and b are constants with m not equal to 0, then x and y are linearly related. If x1, y1 and x2, y2 are two distinct points on this line, then the slope of the line is given by m equals y2 minus y1 over x2 minus x1. We also write this as delta y over delta x. Delta y is the change in y, delta x is the change in x. This ratio is called the rate of change of y with respect to x. Since the slope of a line is unique, the rate of change of two linearly related variables is constant. Some examples of familiar rates of change are miles per hour, price per pound, and revolutions per minute. Example of rate of change. Rate of descent. Parachutes are used to deliver cargo to areas that cannot be reached by other means of conveyance. The rate of descent of the cargo is the rate of change of altitude with respect to time. The absolute value of the rate of descent is called the speed of the cargo. At low altitudes, the altitude of the cargo and the time in the air are linearly related. If a linear model relating the altitude A and the time in the air t is given by A equals negative 14.1 t plus 2880, how fast is the cargo moving when it lands? The rate of descent is the slope of the model, which is m equals negative 14.4. So the speed of the cargo at landing is the absolute value of negative 14.1. This is the absolute value notation. When we calculate the absolute value of negative 14.1, we get 14.1, and that is the speed of the cargo at landing. Here is another example. The speed of sound through air is linearly related to the temperature of the air. If sound travels at 327 meters per second at 0 degrees centigrade and at 351 meters per second at 30 degrees centigrade, construct a model relating the speed of sound and the air temperature T. Then we need to interpret the slope of the model. So we have the variables here. S equals speed of sound. It's already given here. And T is the temperature. Air temperature. Variables are already selected for us. So we have to construct a model, linear model relating S and T. Corresponding to T equal to 0, the value for S is 327. So we can write it as an ordered pair, 0, 327. So this will be the T value, this is the S value. We also have another point, corresponding to 30 degrees centigrade, the speed of sound is 351 meters per second. We get the ordered pair 30, 351. So we are constructing a linear model that passes through these 2 points. So what we are going to do is we are going to calculate the slope. Slope equals y2 minus y1 divided with x2 minus x1 formula. Substituting the values, 351 minus 327 divided with 30 minus 0. So that simplifies to 7 over 15. So slope is 7 over 15. So now we need to write the model. S equals slope times t plus b. So notice that 327 is the y-intercept corresponding to t equal to 0. S value is 327. So we can actually substitute further. M is 7 over 15. So 7 over 15 times t plus the intercept, which is going to be 327. So what is our model? Our model is S equal to 7 over 15 t plus 327. Here is another example. Consider the regression model y equal to 0.92x plus 3.56, where x is the diameter of a tree at breast height, called dBH in inches, and y is the height of a tree in feet. Questions. Interpret the slope of the model. So the rate of change of height with respect to dBH is 0.92. What is the effect of a 1 inch increase in dBH? 1 inch increase in dBH produces a 0.92 foot increase in height. Question 3. Estimate the height of a tree with a dBH of 15 inches. So height of a tree is y. Y equals 0.92. X value is the dBH. So we can substitute 15 for x plus 3.56. And when we simplify this, we will get 17.36, and y stands for the height of the tree, which is measured in feet. So the answer will be y equal to 17.36 feet. Question 4. Estimate the dBH of a tree that is 25 feet tall. This time y value is given. Going back to the model, y equal to 0.92x plus 3.56. We set y equal to 25. And we are trying to find the value for x. So substituting for y, we get 25 equals 0.92x plus 3.56. Solving for x, we get 21.44. That is subtracting 3.56 from 25. On the other side, we will get 0.92x. So if we solve for x by dividing with the coefficient, x will be equal to 21.44 divided with 0.92, which is calculated as 23.30. Unit will be in inches. Objective 2. Linear regression. In real-world applications, we often encounter numerical data in the form of a table. The powerful mathematical tool, regression analysis, can be used to analyze numerical data. Regression analysis is a process for finding a function that best fits a set of data points. Linear regression is used to find a line that is the best fit for a data. A regression model can be used to interpolate between points in a data set or to extrapolate or predict points outside the data set. A graph of points in a data set is called a scatter plot. Find linear regression using a calculator. Prices for emerald-shaped diamonds from an online trader are given in the following table. Find the linear regression model that best fits this data. We have two columns here. We can identify them as x and y variables. So we are going to do this problem on a calculator. These are the steps. On the calculator, push the start button and then edit the data. We put the values under the columns L1 and L2. L1 contains the weight in carats and L2 contains the price in dollars. Now once you enter the data, you can go to the start key again. Go to the calculations. Scroll down and item number 4 is the linear regression model. Notice that ax plus b is written here. Y equal to ax plus b. If we press enter again, we have the regression model calculated for us, which is y equals ax plus b, where a equal to 5,475, b equal to negative 1,042.9. Now we are going to plot these data points to get the scatter plot. Once we have the data entered, which is already here, what we can do is we can go to second y equal to, which is the stat plot, pick one of the stat plots and switch it on. So we have on off keys here, highlight on and then press enter, that will be selected. Then scroll down and the scatter plot is the first item there. Again select. Now we are going to change the window. Press the zoom button and then press 9, which is zoom start. The graph showing up in this window here. Supply and demand. In a free competitive market, the price of a product is determined by the relationship between supply and demand. The price tends to stabilize at the point of intersection of the demand and the supply equations. The point of intersection of the supply equation and the demand equation is called the equilibrium point. The corresponding price is called the equilibrium price. The common value of supply and demand is called the equilibrium quantity. The table contains price supply data and price demand data for corn. We need to find the linear regression model for the price supply data where x is the supply and y is the price. So y is the price, x is the supply. Same thing up here, y is the price, x is the demand. So we have two data sets here. Find the equilibrium price for corn. We are going to find the linear regression model for the price supply data. Go to the start and then select edit. We need to enter the data here under L1, L2. Notice that x is the supply, so we need to put the supply values under L1. So in order to clear this data, we need to go to the list name and press clear, enter. So we can also clear L2 by going to the list name, press clear, enter. Now we are going to put the supply values in L1 column, 6.43, 7.47 and so on. And in the L2 column, we put the price values, 2.17, 2.27 and so on. Now we need to find the regression model. So that means we need to hit the start key, go to the calculations, which is right arrow, select number 4, linear regression, press enter. So we get the model as y equals 0.1963 x plus 0.8789, rounded to 4 decimals. So the supply model is y equals 0.1963 x plus 0.8789. X equals supply, y equals price. We are going to calculate the linear regression for the demand. So again, press start key, go to the editor. X values will be the demand values, which is 9.97, 9.44 and so on. In the L2 column, we are going to put the price values, 2.06, 2.12. So to get the linear regression model, go to start, right arrow for calculations, number 4 for linear regression, enter. The linear regression model for the price demand is y equals negative 0.1350x plus 3.4038. X equals demand, Y equal to again price. Here is question 3. Find the equilibrium quantity and the corresponding equilibrium price. So in order to get the equilibrium quantity and the equilibrium price, we need to equate the supply and demand. We can do this on the calculator too. Edit both the supply model and the demand model as Y1 and Y2. Now to calculate the common value or the intersection, second trace number 5, which is the intersection, then we can press enter 3 times to get the intersection point. X equals 7.6212 and Y equals 2.3749.